Hello and welcome to video 12D of Foucault's Pendulum for Advanced Experimenters. Today's video will not be an experiment, but it'll be a reply to my good friend icansciencethat. He has a YouTube channel, and icansciencethat and myself were involved in a internet hookup to answer some questions about where I'm up to with the pendulum, and just as we're about to ask the questions, a critical moment, the internet died on us. And you can catch that video if you like in the bottom of the description. But at the moment, at the end, he managed to keep going his end, and he asked me some questions, and we're replying to those questions now. First question involved my last experiment. That my last experiment had no precession in it, and I've eliminated a lot of bias, and I'm operating a very precise pendulum. So he asked a fair question was, well, yours seems to be going no precession. Is there any doubt of the existing ones out there on display? A fair question. No malice meant with it, just a curious mind at work. I'm not ready to make a call yet. I think I'm 20 experiments off that yet. So he also pointed out that, hey Peter, like there's lots of really strong indicators that the Earth is spinning. We've got some very precise, well-known, without question, devices out there showing the Earth spins. How do you react to those? And one of them was, well, how do you react to the fact that magnetic gyro compasses, in fact, show the Earth is spinning and precesses? Well, yeah, hey, they do. No question, they are a fantastic device. They are used in aeroplanes. The precision is without question. Except they're made from metallic componentry. Now, I'm waiting for the ceramic or the zirconian turbine one to be made before I make that call. So it's still in the pipeline, I believe, so I don't know where they're up to, but there will be a purely non-magnetic turbine made sometime. Again, with optical gyros. Wow, these are almost affordable now for the average person. They come down in price, and without question, they show precession of the Earth. Very accurate. But we still not have measured the speed of light. So why are we entertaining this? This is not even, cross this one out. This is just, no, don't go there. Also, there's just other general YouTubers, people who are coming up with great ideas and other concepts that back up the claims that the Earth is spinning. And he pointed out someone like, he said, have you looked at Critical Think's channel? He's doing various weight measurements throughout the world, and he's got a lot of people on his side doing these, helping him out. Great. Look, as far as I know, he's a true shooter. Yeah, good on him. He's an experimenter. Let's go, more of them. But the only thing I might think, is he using metallic weights? And I believe the measurements are static. Now, as you know from my ramp experiments, the measurements have to be made dynamic. We cannot do static measurements on weights. So, if you remember, I'm in that process as well of going down that channel, and here's I have my dynamic pi squared tube. Now I'm going to use the same concept, but this is just a follow-on from my ramps. Now these will be vertical. It'll be a vertical glass tube. It'll be dropping these and measuring the force on these zirconian oxide non-magnetic ball bearings, and it'll be a sealed container, evacuated sealed container, Wi-Fi driven, go on an aeroplane, can be sent anywhere around the world, very cheap. Anyone can set it up, and we can do dynamic force measurements on this weight concept throughout the world. Very cheap. I'm looking at designing these to be, you know, in the $50 mark. So mass produced, even cheaper. That is also in the pipeline. So as far as critical think, yeah, good. Except I believe it's still a static measurement, but I'm not. He could have been developing something else. I'm not a person to question that, and certainly not an experimenter. Also, I believe a gentleman by the name of another YouTuber, Wilberforcing. I've watched a couple of his YouTubes, and as far as I'm concerned, this man is a true shooter, and he's no BS from this man. So he's making measurements that there's different weights from the east to west direction. Hey, like I said, this man's got no BS, so he's got my attention. This could be something in this. How long is my pendulum? Well, it's 2100 millimeters long, as it stated in the other videos. And I've always left it up here on the screen. And our last swing was 340 millimeters. Why do rockets... Can you explain this? If the Earth is not spinning, why are we always launching rockets east to west to save fuel? Very good question. Now, okay, icansciencethat is only a young man. He wasn't around in 1969, and we all asked this question as well. And we asked that question was, oh, you're saving fuel. Wow, that's east-west direction. That's really good. Wow, this is really good. And then someone said, well, hang on. If they're really serious about saving fuel, why don't they just knock off that extra 300 kilos of ice hanging on the stage one of the rocket, and they'll save lot of fuel. Because then you can take some more cameras and you can take some more video, so we can actually see that really good video that we all want to see. So, yeah, maybe you could, if you could answer that question for me, yeah, that would be good as well. So, all right, so let's move on now to the other questions he moved, which are, let's move on to that section now, and I'll just come back. So here we are with the technical questions that icansciencethat was trying to get through to me before the internet failed, and the big question was, should the minimum length of a Foucault pendulum be greater than 12 metres? It's very controversial. There's a lot of for and against this. So I can just give you a quick summary of what I've found so far. And basically, the longer the better. Yes, I agree with that. You'll get a better swing time, you'll get more precision, more accuracy with your processing measurements. Great. And you won't need to go to mechanical assist. Great. Go for it. However, your cable's going to cost you more money. You're going to have a special wound cable. Foucault had to get special anti-creep cable made. They're not cheap. Your location, 12 metres without any air. These things are dangerous. People run into them, they get hurt, their safety. Your bob, precision ground 12 kilogram or 5 kilogram bob, it's going to cost a fortune. Okay, but if you can afford it, go for it, yeah. Okay, this is another one. There's two camps here. Foucault pendulum works on Coriolis. The Foucault pendulum doesn't work on Coriolis. I've stayed out of that debate. But hey, we've now got a pendulum 12 metres high or longer, higher. The bottom's going slower than the top. There's a debate here starting already on Coriolis. We've got potential differences in speed of our length of our pendulum. Issues of Wilberforcing, we'll get into that next. Foucault's early experiments were done in his garage by a 2 metre long pendulum. Hey, he did it with 2 metres. His early experiments were done with 2 metres in his garage. Now, the short answer is, what am I doing? I'm following Foucault. I have to stick to his parameters, and that's what I'm doing. So mine is 2 metres, so that's a short answer, yes. Just another little side note, icansciencethat has actually visited his local observatory where they have a Foucault pendulum, a 40-foot pendulum, and it's doing the right thing. It's on display, and just ask him this question, which comes up quite a bit. It's quite funny. You'll go there and you'll get this from an operator. Yes, all Foucault pendulums need to be at least this length of 12 metres and greater. And okay, it's going to be hard to build one of them. Yep. And then they walk into the gift shop, and you can buy a little 500mm pendulum that does the same thing. So just something to note. All right, let's move on now to Wilberforcing. So what is Wilberforcing? Wilberforcing is quickly explained by a Wilberforce pendulum. A Wilberforce pendulum is a pendulum on a spring. And when it's swung, it randomly jumps around and does chaotic conditions. Now, you don't want your pendulum in any way experiencing random chaotic effects. And as we know, our pendulum, the objective of our pendulum is to stay within an exact arc of a circle. Perfect circle arc. Now, when our pendulum swings at the bottom, the load on the pendulum is maximum and the load on the cable is maximum. As the pendulum creeps to the point where it's just about to come back, the pendulum becomes almost weightless, and if there's any retraction on that cable, it will pull the pendulum to a new position, and it will be a new arc temporarily until it comes back down. So you won't get that perfect isochronous curve, which is essential for a stable, reliable, accurate, precessive generating pendulum. Now, how do we measure Wilberforcing? It's very hard to measure dynamically, but you can do a static measurement. And what you do is you'll get your cable and you'll measure it. You'll hang your plumb bob day 1 and come back in 4 days' time. And if it's grown in any length, you know you've got potential cable that could have a creep factor or that spring factor. So you have to get rid of that. It plagues pendulums. It gives them incorrect results. And I didn't want to get into the cable at this early stage, but icansciencethat has wanting to get in this 12-metre cabling pendulum. So just a word of warning for him, if he wants to get into 12-metre, you will start getting Wilberforcing in 12-metre lengths. You'll get it at any length, but it's really pronounced because you're looking at cables that are now steel cables. They'll have spring in them. Unlike my 2-metre cable, which uses optical fibre, it's cheap. You can buy it anywhere. I'll get onto that, how to make your cable later on, but my cable is made from fibre optic glass. It has got zero creep. I have built in a magnetic detector that if the pendulum does experience Wilberforcing, it will actually dislodge from the coupling at the top. So it'll come to this point and there'll be this jerk and it'll release. So I've got that sort of built in. And I'll talk about that later, but we're not there yet. Just an introduction for icansciencethat. All right, the next question was to do with the angle measurement. So let's get into that now. Okay, here's my response to icansciencethat. He was after a precision angle measuring device. This is what I've had made. I haven't used it yet because at this stage we're just measuring precession, just to see if we're getting precession in the right direction. It's 2 pieces of timber that swivel at a point in the centre here, which goes directly under the plumb bob, and at the other end I can actually measure the precession of the pendulum with this indicator at the other end. And the measurements of this timber, this sliding timber, I'll give it to him later if he wants it. So that's what I have for my precision angle measurement. However, I did find the laser more accurate on the wall, but I have an open mind to what his requests are, and hopefully this might help him out. Alright, hopefully I've answered all the requests that icansciencethat has put out to me, and those requests may also be interested to the viewer who's watching this video. In addition, if you'd like to see the video that icansciencethat and myself, the podcast video, that will be on the description below, and it is basically the journey that I've undertaken to get to the pendulum through the flat earth investigations and all that. Also, icansciencethat is a very articulate gentleman, and he cleans up my conversation. He virtually goes, listen to what I say, and then he goes over it and cleans it up in a much more precise, articulate way that easier to understand. So it's quite an interesting video. I looked at it later on, despite the glitch in the video with the internet. So, and also we actually came across some other discussions, some tangents that you also may be interested in. So I recommend that. So as I said, the link below. Thanks for watching, and we'll see you in the next video.